Hello good people, I'm going to explore the gradient of a straight line and how to calculate it. The gradient of a line represents a change in y due to a change in x. In mathematics, we have a special symbol for the words a change in, and that symbol is this little triangle. It is a lowercase Greek delta. So often when we talk about a change in y, we could also talk about delta y. You might be wondering, what does a change in y actually mean? Well, when we talk about a change in something, we are talking about a difference. And so the gradient is also often written as m equals y2 minus y1 over x2 minus x1. You may have also encountered this as rise over run. Let me bring in an example. Suppose that we are monitoring the height of a tree over a number of years. At year 0, when we start our measurement, the tree is already 6 meters tall. After 1 year, it is 8 meters tall, after 2, 10, after 3, 12, and after 4 years, it is 14 meters tall. These ordered pairs can be plotted. Recall that time is the ultimate independent variable. Therefore, years will go on the x-axis and height in meters will go on the y-axis. Here are my x's, and now I'm going to quickly plot the points. What is the gradient of this blue line? From the table alone, we can say that for every year, the tree is growing by 2 meters. Therefore, the gradient is 2 meters. But let's see if we can also calculate it using the formula for the gradient. At this stage, you might be wondering, what do these y2, y1, x2 and x1 represent? They represent the coordinates of 2 points. Which 2 points should we use? It really does not matter so long as the points are on the line. I'm going to choose these 2 points, and I'm going to make this point 1 and this one up here point 2. This means that the coordinate 1, 8 represents x1 and y1, and the coordinate 3, 12 represents x2 and y2. And now I can substitute. y2 minus y1 becomes 12 minus 8, and x2 minus x1 becomes 3 minus 1. 12 minus 8 will give me 4, and 3 minus 1 will give me 2. 4 divided by 2 is 2. Therefore, I can say that the gradient is 2 meters per year. In order to demonstrate that which points I choose really does not matter, I'm going to do this whole thing again with 2 different points. This time, I'm going to make this point 1 and this point 2. This means that the coordinate 2, 10 now becomes x1 and y1, and coordinate 4, 14 becomes x2 and y2. Once again, I'm going to substitute. And now I will have 14 minus 10 divided by 4 minus 2. 14 minus 10 will give me 4, 4 minus 2 will give me 2, and 4 divided by 2 is 2 once more. Now that I have definitely shown that the gradient is 2, I could also write the equation for this particular line. And it would be y equals the gradient, which happens to be 2, multiplied by x, plus the y-intercept, which happens to be at 6. Note that the gradient does not have to be positive. If our line, when read from left to right, is going up, yes, we are expecting a positive gradient. However, if the line is going down, we are going to end up with a negative gradient. So let me look at another example. This time we have a saline solution that is being delivered to a patient. At the start, the volume is 800 milliliters. The saline is being delivered at a constant rate, and so after 20 minutes we have 600 milliliters, after 40 minutes 400 milliliters, after 60 minutes 200 milliliters, and after 80 minutes the bag is empty and the volume is 0 milliliters. In order to plot these ordered pairs, I will need some x's. Once more, time, the ultimate independent variable, will be on the x-axis and volume will be on the y-axis. Now that I have my x's, I can plot the points. The line, when read from left to right, is going down. Therefore, I am expecting a negative gradient. To calculate the gradient, I will need the formula for the gradient. And now I need to select 2 points. Remember, it does not matter which points we choose so long as they are on the line. I'm going to choose the point at 2600 and I'm going to make point 1, and I'm going to choose the point at 6200 and I'm going to call that point 2. That means that 2600 represents x1 and y1, while 6200 represents x2 and y2. I can now substitute into my formula. And so I will have 200 minus 600. All of that divided by 60 minus 20. 200 minus 600 will give me negative 400, and 60 minus 20 will give me 40. Negative 400 divided by 40 will give me negative 10. I expected a negative gradient, and I have ended up with a negative gradient. It happens to be minus 10 milliliters per minute. This means that the bag of saline is losing 10 milliliters every minute. What would be the equation for this straight line? Well, I would have y equals the gradient, which happens to be negative 10, multiplied by x plus the y-intercept, which is at 800. In summary, to calculate a gradient of a line, we need 2 points that happen to be on that line. If the line is going up, when read from left to right, we are expecting a positive gradient, and if it is going down, we are expecting a negative gradient. That is all for now, and I will see you on the flip side.